All right, so here we are in section 11.2. This is the second video, and so in this one I'm going to show how you can solve a system of three variables with three equations. For the two-variable case, we introduced the substitution method and the addition method. Those two methods still work for three variables. They can work for any number of variables. So in this problem, I'm going to demonstrate the substitution method. But future problems, I'm going to be using the addition method more and more often, and eventually we're going to use something called Gaussian elimination, which is sort of an extension of the idea of the addition method, and that'll be the more standard approach. But for this first one, I want to go back to the substitution method. So with three equations, it gets a little bit more difficult to manage the three equations and like remember what you're doing, which equation you're working with. So what I'm going to do is number them. They'll always be numbered 1, 2, 3 throughout this process, and we'll be using that to kind of keep track of what we're doing. I recommend doing that in your own work as well. It certainly makes it easier for me to follow along with what you're doing. So please follow my lead on this. 1, 2, 3. For the substitution method, we want to pick an equation and solve for a variable. I'm going to pick equation 1, and I'm going to go ahead and solve that for x. So if I solve for x, all I need to do is subtract the y and the z from both sides. So I'll get x equals 3 minus y minus z. So now I'm going to take the 3 minus y minus z, and I'm going to substitute that in for x in the other two equations. So 2 is going to become 3 minus y minus z, that's the x, and then plus 3y, and then plus 2z equals 14. So that should simplify. Let's see, there's no x's, so the y's, we're going to have negative y plus 3y, that'll be 2y. For the z's, we have negative z plus 2z, which is going to be plus 1z. And for the constants, I'm going to subtract the 3 from both sides and move it over here, so 14 minus 3 is going to be 11. So that's what I have, 2y plus z equals 11. All right, so that was equation 2. We did the substitution, and then we simplified it. Now let's take equation 3. We'll do the substitution. 2 times x, except x is going to be replaced by 3 minus y minus z. Smaller. So 2 times x plus 4y minus z equals 5, like that. So now we'll simplify it. First, distributing the multiplication by 2, we have 6 minus 2y minus 2z plus 4y minus z equals 5. And then let's do like I did last time. First, the y's. We have negative 2y plus 4y, so overall that's positive 2. For the z's, we have negative 2z minus another z, so that's overall minus 3z. And then for the constants, we have the 6 over here. Let's subtract that 6 from both sides. So 5 minus 6. And on the right side, we'll have negative 1. So now we have equations 2 and 3 have been simplified, and they are now, they basically form a system of two equations with two variables. So by performing this substitution, what we've done is eliminated the x variable and boiled this down, like reduced it to a two-variable system of equations, which we can now solve in whatever way we want. So what I'm going to do is I'm going to take this equation that we got for number 2, and I see that I can very easily solve it for z. So I'm going to do z is 11 minus 2y, and then I'll use that to make my next substitution. So I'm going to continue working with equation 3 here. Using z is 11 minus 2y, we're going to substitute and get 3 times 11 minus 2y equals negative 1, like that. And then let's simplify that. Oops. We'll have 2y minus 33 plus 6y equals negative 1. All right, we're close. 2y plus 6y is 8y. And if I add 33 to both sides, we'll have negative 1 plus 33 gives me 32. So 32 is a multiple of 8, right? What is that? That's 4 times 8? Gosh, my mental arithmetic is awful. So divide both sides by 8, we have y equals 4, and we are on a roll. We are we have having found one of the values of the variables. Now we can go back and do what we call back substituting. So we're going to go back up to the previous equation we were working with. Let's take equation 2 here, which was z equals 11 minus 2y. That's going to be now z is 11 minus 2 times 4. So 11 minus 8 is going to be 3. Z is 3. Now taking those two values and going back to equation 1 finally, x will be 3 minus y, which is 4, and then minus z, which is 3. And that gives us x is negative 4. So there we go. We started here, we worked down here, and then we worked here, and we ended up finding the values of all three variables via the substitution method. So our solution is the single point where x is negative 4, y is positive 4, and z is 3.